Good evening and welcome to today's webinar. We're going to be looking today at desktop app automation, specifically how you can use the Test Evolve tool to automate POS systems as part of an omni-channel flow. So let's take a quick look at what we'll be covering. First of all, I'll do an overview of desktop app automation. So when it's needed, what available solutions are out in the market at the moment. We'll also obviously be looking at the Test Evolve solution. We'll be looking at requirements, so how to create BDD requirements that work for desktop app regression, specifically POS system regression, looking at critical flows that should be covered, and what can and can't be tested as part of this. So we'll also look at common challenges associated with automating till systems. So things like slow running till system will cause issues. We'll see why. Things like different languages, if you've got till systems that work across multiple languages, some of the flows may be different depending on the region. We'll look at that as well. And recovery flows, so things that are easier in browser automation, such as restoring the state of the browser afterwards. You need to do the same with restoring the state of the till. So we'll look at test runs and test cases in there. I'll be performing a demo of Test Evolve Flare. We've got a new feature that provides an accelerator for desktop app testing. It makes it a lot easier to collect images and store them in a screen object model. And we'll also be diving into the code. So we'll look at a typical flow on Oracle XStore till that's in a test lab in Porto. Okay, so let's dive in. Okay, we're seeing more and more that test automation needs to reach outside of typical e-commerce flows. So we can automate just placing an order on a website and prove that the site is working. But most organizations will have flows that go outside of that. So you'll have omni-channel flows, for example, creating a customer in a back-end system, a CRM, or some maybe even just on the existing website, creating a customer. And then in a mobile app, they may want to reserve something at their local store. And then in that store, they may need to be able to find that customer in order to process that order. So any modern test automation tool should be able to reach outside of just automating a web browser. You need to be able to handle native apps on Apple and Android, be able to perform API or database queries. There's going to be some legacy applications that just don't have a web interface. You may be able to access them another way. And then for some till systems, it may be that you have to treat them as a desktop app. It's a Windows application, for example, and that hasn't been modernized yet. Or it could be a legacy financial system that just is never going to be updated. So these things need to all be taken into account. We obviously know that the POS software is crucial. It really can't fail. If you've gone into a store, if you've ever worked in retail and the till system's gone down, it's a horrific experience, not just for the customers but for the staff as well. There's obviously going to be a revenue impact if you're non-transactional for any amount of time, if the card readers aren't working, for example. So yeah, the impact is potentially huge. So when we're talking about testing, we're talking about introducing automation testing to all areas because it's just necessary. So obviously manual testing of POS systems is quite laborious. It's effectively putting transactions through in multiple different ways, different variations. And I myself worked at McDonald's as a test engineer. I was putting through Big Macs and Big Mac meals in different variations. And we just had a regression pack that we had to kind of work through because when, before pushing to the hundreds of stores that McDonald's have in the UK alone, you need to be really confident in that software. So yeah, the manual regression testing, it serves a purpose, but it can be optimized. So transitioning from manual to automated testing of a lot of the crucial flows, just knowing that when I put through a Big Mac meal, I'm not going to have any errors, or if I use this particular discount voucher, everything's going to be okay. And obviously with test automation, it can run 24 hours a day. It's not reliant on humans. Humans still have to look at the results and interpret them and make decisions based on them. But the effort put into automating it is almost always worthwhile. We can then use our manual testers in another way. So most manual testers are really, really familiar with the till system. They know where the pain points are. Potentially, a lot of them have actually worked in retail on those systems before. So it's important that we use them in the best possible way. So experience-based testing, having them manually explore a release while the automation covers all the basics that, the many transactions that need to be done. The manual tester can go away and explore and look for the things that they suspect are going to be a problem in the new release. And as always, so at TestEvolve, we're really keen on upskilling manual testers. So if they want to be involved in coding, we've tried to make our product as simple as possible. The transition doesn't need to be difficult. If you've got enthusiasm for coding, the syntax is really simple, and we'll show you that later. So there are available solutions for POS automation. With more desktop app automation, you don't normally have something that's specific to a till system. I guess you'd have XUnit as the example in Xstore, where it's kind of very unit test based. It's not end to end, but it's specifically for a till system. But most solutions will be more general than that. So, for example, you'll have a Selenium adapter for example, WinApp driver. It'll only work on very specific Windows applications. So that isn't much use if you've got a Java Swing application, for example, that you need to test. So we're really looking for a one-size-fits-all solution here. If you're writing automation tests for a new modern web-based application, such as Xstore, the new version of Xstore, or some of the other till systems that are out there at the moment, they're kind of cloud-based. So if you're writing test automation for those, you can still use Cypress, Playwright, and TestEvolve. You'll just be able to hook into them exactly the same as if you were testing a web application. And that can be really powerful, but not all tills are that way. Not all applications are that way. So the other option is Sakuli. Sakuli is a good example of an image recognition bit of software that will look for images in an application, and then it will interact with it based on finding those images. And that's very similar to what we've done with TestEvolve. So we do this thing called sub-image search, where we instead of using elements like a input with a data test tag in a website, we would have a screenshot or a screen of a POS system, and then we're looking for a particular element on that, and we can use that to click to drive the automation forward. We couple that with OCR, so optical character recognition. It's the idea of reading text off the screen so that it can be used, and this is really useful in test automation of POS systems. Imagine, for example, you're doing a scenario with exact cache, which is what we're going to do in a minute. You need to be able to fill in the exact amount of cache that the sale transaction comes to. You need to be able to type that into the till as a user would. So we need to be able to read that in the first place. So we've built that into the TestEvolve solution, and it's really powerful. On to POS automation requirements. It's really important that we identify the critical flows. I'd highly recommend getting close to someone in the business or someone who uses the till regularly in order to identify what the critical flows are. So obviously Cash and card transactions are going to be up there. Refunds, you have to be able to process a refund, probably legally. Discounts, customer satisfaction is highly dependent on not being able to get the deals that they want. And then the end of the day operations, it's really important that the information gets uploaded. You're able to close the till down at the end of the day, count the cash, upload the end of day sales, that kind of thing. So these are just some examples, but it's really important that you get close to someone in the business who can give you these requirements. We've got an example of one here. It's a very basic one. It's the one we'll be using today. But as a retail store cashier, I want to process different types of sales transactions so that I can serve customers efficiently and accurately. So this would be a really common requirement. Different types of sales transactions, obviously that is going to look at cash and card transactions, possibly vouchers. And we'll look at how to change that into a BDD requirement. So normally with BDD, you're developing the system from scratch, and you're creating the requirements that the developers will use and the testers will use, and they'll be based on what the business wants. Most of the time, if you're working at an SI, you'll be coming in and the till system will already be there, so you're having to retroactively build the requirements. There may never have been any, or at least they're not documented anywhere that you can find. So let's have a look at creating a BDD scenario that deals with this requirement here. So let me flip over to Testable Flare. Flare is our studio application, and I'll talk about this a little bit more when we actually get to writing the automated test. But for now, I'm going to click on the test recorder in the left menu bar here, and we're just going to write out our BDD scenario. So I'm going to create a feature first of all, and let's call it X Store Testing. Okay, and then we need to give the scenario a name, so let's call it a simple cash transaction. And the step, so the first step is the given step. For those not familiar with BDD, it's basically breaking down requirements into very human readable language that the business can understand, the testers, the developers can all understand, and give a common understanding of the feature that you're trying to develop. It's basically the blocks are given, when, then. Given will set up all the prerequisites for your test. So potentially some test data that needs to be there, or performing an action as a particular user. You need to set that user up. The when step is performing an action, which is the basis of the test. So, trying this new feature. And then the then step is basically checking the outcome of the test is exactly what you expected it to be. So some kind of verification in the then step. So for our requirement, it's as a retail store cashier, I want to process different types of sales transactions. So for the given step, we need to make sure that a cashier is logged into the till. So given I am logged into the POS as a cashier. And then the next step would be the when step. So we're processing different types of sales transactions. So the first thing we need is an item that's in the transaction. So we could say when the transaction is in progress, or let's do when I add an item to the transaction. And we'll add an and step. You can do and also but. So the particular transaction that we're going to do is an exact cash transaction. And complete the transaction with exact cash. Okay, and then last of all, we want the verification step. So when the cashier has added an item to the transaction and completed the transaction with cash, what should they see? Well, they should see that the transaction is processed successfully. I haven't looked at the till yet, so I'm not 100% sure what that will look like, but when we get around to recording that step, it will all become clear. Okay, so this is our BDD scenario. We've created it using the test recorder in Flare, but if we flick to the IDE now, we can have a look under features, and it's built our XStore testing scenario here. So we'll come back to this later and we'll record the steps underneath it. Let's look at some common challenges associated with automating a till system. The biggest problem you're likely to face is recovery flows. So after a test fails, where it is on the system, how do you navigate back from that state that it's in order to get back and ready for the next test to execute? So some recommendations, obviously before a test run, you need your till system to be in a certain state. It's no good if it's closed, the register's closed, the store's closed perhaps for the day. It's best if they're open and ready to go. You don't want to have to rely on a sequential list of tests where the open happens first. You want to keep your open and close tests separately. And they can even run as an independent test run if you like. But at the start of a test run, it's probably best that you have your store open and your register open, ready to trade. There's an argument to be made that a user should also be logged in. But a couple of things against that. One, most till systems would have some kind of timeout or for security reasons where it would exit back to the login screen anyway. And two, you might want to have a different type of user. We're going to deal with a cashier today in our automated test, but it may be a back office manager or a supervisor needing to log in. So being able to use that in the given step of any given test, I think is important. So yeah, on the login screen and open, ready for business. If there's any kind of training mode or anything like that, it needs to be exited out of that in order to start each test. So and start a test run. So for each test, wherever you are in the flow, whether the test has passed or failed, you need to kind of be able to know where you are and exit out from that. And there's a couple of things you can do to almost cheat that. Potentially, depending on your till system, there might be a series of keys that you can use to exit back to the default screen. Certainly in XStore, the escape key will get you back most of the time. There are some exceptions. If you're in a return flow, for example, then it might really object to you trying to escape out of it because it's partway through a refund. So there are exceptions, but these can all be handled in hooks, and I'll show you an example of a hook later. But you can build before scenario hooks and after scenario hooks to get you to the state that you need your test to be in. Other issues, so timing issues. If you've got a slow till system, slow software, maybe some older software, or even just the hardware causing the software to run slow, this can cause problems because automated tests are very quick. We need to know that the screen has successfully transitioned. We need to know that the state has changed and then proceed with the actions we want. So there are ways around it, and I'll talk about the robustness later as well. In terms of continuous integration, so with this method, you need effectively one machine to run one till. When it's a real till in a test lab, you need a machine executing the test, and then you need the till itself. And that's because we're basically remoting into that till, and then we're executing the test remotely, driving it remotely. So that can cause problems in that you can't scale it up in the same way as you could an automated test, where you can just open multiple browsers. For a web test, you can just open multiple browsers and execute the test across those. It's harder to do. It's not impossible. It's certainly possible. You just need multiple machines running against different tills at the same time. tolerance, so we've got a configuration value that allows you to have a certain degree of difference between the image that you collected and the image it's found on the screen. So you might have a tester that has collected the images on a Mac OS machine and then it's being executed on the Windows machine, and the Windows has a slightly different color profile which affects how it's displayed. And in that case we can say, okay, it's 85% similar, and therefore we want to continue and interact with the button or whatever we've saved element wise. So we have a tolerance setting. It's best to keep the resolution that you're executing the tests on the same as the resolution you have collected the elements on initially, and ideally you'd be collecting the elements on the same machine that you're executing the tests on. And that just avoids any scaling issues or any complications down to the resolution of the screens. It's become very common to execute tests on a machine locally with kind of an emulated or a simulated version of the POS software. I'd caution against it. There's lots and lots of errors and complications that come from having the hardware installed. So it may work perfectly on your machine, but there's nothing better than having a test lab with a configured till system, based on region and that kind of thing, with all of the devices that an end user will be using in their store plugged in and ready to go. Having said that, there are some exceptions. So I think a printer should always be disconnected. We have a pretty funny story actually, that we had a manual weighing scale attached to a test lab POS, and the receipts were constantly printing and they were falling onto the scale. So when we were trying to enter a weight for an item manually, it was saying, no, there's an item on the scale, you can't continue. And we just couldn't figure it out until someone actually went to the lab. And that's one of the challenges of working remotely. Someone went to the lab and cleared up all the receipts, but it's a huge waste of paper if you're putting through hundreds of transactions, as hopefully your automated test will eventually do. Stopping that waste of paper and stopping it impacting anything else as well. So we can handle regional variations. This can get tricky. If there are different languages, then obviously we're looking for a button with particular text on it. In our sub-image search, an element will have particular text. So if it's possible, if you've got tills that have buttons in other languages, you could potentially change that language to English, because then you're still testing the functionality. It's literally just a display change of the text that's displayed. But that's one way around that. And if that's not possible, then it's completely fine. You can collect images for the variations, and we have helper functions in Test Evolve to just specify a language variant of the image that you collect. In terms of functionality based on region, you've got your full regression pack. You want to be able to run it against all your tills, but some tests will fail because that functionality isn't there. So for example, sales tax in the US might not be present in the UK. So we can deal with that with tags. I'll show you an example of that when we get to the demo. But each scenario can be tagged with a certain, readable tag. So we could say not UK or UK only or something like that. We can specify that, and then when we do a test run against the US till, it will not include that UK only functionality. Okay, let's move on. Okay, so let's dive into a demonstration of how we'd use Test Evolve to automate a till system. So first of all, I'll talk about my system setup and make a recommendation as to how you should set your system up if you choose to do automation this way. I'll show you a new feature in Test Evolve Flare called Element Collection that accelerates our ability to automate the desktop apps. And we'll dive into the Ruby code as well and show you how it's used to drive the till. Finally, I'll talk about how we can make our test more robust when you encounter issues such as slow running till, things that we talked about earlier. Okay, so let me first talk about my setup then. So I've got two screens. One has got Flare on it, and the other has a remote desktop connection to a register that's in a test lab in Porto. So the register itself has a remote desktop installed on it because it's a Windows machine. My Windows machine has remote desktop as well, so I'm able to connect to that register this way. I'm able to send keys. I'm able to click on buttons and control the register remotely. So this is basically going to be how we drive the till through this remote connection. I'm using remote desktop, but you can use other products. So we've done integrations for TeamViewer and GoToResolve, for example. If there are others out there, maybe your IT support team uses a particular software to connect to tills in production. So that might already be installed on your tills, but that's the only thing that needs to be installed. Everything else is done remotely. Everything's driven remotely. Okay, so let's come back to Flare. This is just a basic project that I've just created. It's I've named it Extra Automation Demo. You can see that it's using Ruby 3.2.4 and the latest version of Spark. It's got a few scenarios already created, a few features. These example tests are web-based though, so we won't be using those today. And we have our scenario that we recorded earlier. So if I go over to the left-hand side here, we now have the element collector option. I'll click through there, and first off, what will be shown is the contents of an element capture page that's on testvalve.com, and this is just a demo page that kind of allows us to demonstrate what we can collect, different elements, different inputs, a variety of different things. So on the left-hand side is a list of pages. So there's only one page in this particular project, and that's the home page. So when I click through to that, I can see the elements that are associated with that page. At the moment, we've got, for example, my button, which is a button that has a data test tag of example button. So that's on this page. So as an example of how we collect these, so we go to collect mode in the top right. We enable that, and then I just click on, say, the click me button, for example, as that an element. We can then give it a name for our automation purposes, and we can select which attribute we want to use as an identifier. Data test tags, if your developers are nice enough, they'll put data test tags throughout your application. You'll be able to use those as unique values. But, ID, name, value, these will usually be sufficient. When you get down to classes, these can change, especially in React apps, and XPath, which can become fairly brittle. So that's how we do it with web elements. But of course, today we're focusing on screen elements. So if we come back to this page, and then we can select screens from the drop down. So currently there are no screens in this particular project. So let me create a new screen. And the first screen that we're going to be interacting with for this test is the login screen. So let me create the login screen. And you can see it will give us the class name, the method name that we'll be using, and the file name for this screen object file. So let me create that. So it appears on the left-hand side. Let's click into it. And you can see that there are no elements currently listed here. So we will collect some. So next up is selecting the monitor that we're collecting images from. So I've got 3 here. One's got Flare, and this one here is the one that has the remote desktop connection. So I'll select this one. And there we go. We can see the screen mirrored in Flare. Right, so what we need to do first is step through what we need to record. So I'll switch to the POS. So we're on the register login screen. We're looking to log in a cashier. So I've got the details of a cashier. It's 100 and then 1. So the next screen we'll see is the commissioned associate screen where you can select associates. I'm just going to default to the top one. So the first thing we'll need to do is press OK. And then Xtor can be configured in a number of different ways, but under this configuration for this till, the first thing it wants you to do is search for a customer. But for the purposes of this test, we're going to assume that there's no record of the customer previously, so it's just a new customer, a guest. So we'll click on the skip button. And then we can see we're successfully logged in, and we've got the transaction panel and the scan item panel, so we can see that we have successfully logged in. Okay, so we want to step through that process, but recording the elements now. So I'll go back to the register login screen. We want to know that we're on the register login screen before we start putting in credentials. That's a crucial first part of the test. So I'll switch back to Flare. And I'll start collecting elements. So the lock symbol is probably the best identifier on this page, on this screen. So when I select that, it appears on the left-hand side as an element. It's called unnamed element to start with. So let's give that a better name. We're going to call it lock logo. All right, so that's saved to our screen object class. If we switch back to the pods, so the next thing we do is type 100, press enter, type 1, press enter, and we appear on this screen. So the next element that we're interacting with is the OK button to select the default associate. Okay, so switch back to Flare, and we need to refresh the screen now because it's reloaded. So yes, so let's select the OK button. There we go. And let's give it a really original name, OK button. Great. So back to the pause again. We've clicked on the OK button, and next one we want to collect is the skip button. So switch to Flare, press to refresh, and let's collect skip. So for consistency, I'm going to name it the skip button. And then switching back to the POS, the last thing we want to collect is some identifying feature that shows that we're no longer on the login screen, there's no errors, and we're successfully logged in. So I think the barcode image is probably the most likely candidate here. We could use the associate John Smith text here. We could collect that and then search for that. But if someone changed the test data, I'm guessing this is test data John Smith, someone changed the surname, for example, then that would no longer work. So the barcode element will always be there. So let's switch back to develop. We'll then collect that barcode image. And then for consistency, I'll call it the barcode logo. All right, we've got our 4 images stored then under the login screen class. So let's switch to the IDE. We can see on the left-hand side here, so our images are saved here. We've got our new login screen object class. The screen object class is exactly like a page object class, aside from the fact that elements are defined with the image name, rather than the data test tag or some identifying feature for a web element. So it behaves in exactly the same way. We've got this login screen, and the first thing we want to do is create a login method that we can run in order to log a user in, log a cashier in. So we'll define the login method. The first thing we're doing in this method is checking that we're on the login screen and ready to start the test. So that will be, we effectively want to raise an issue, raise an exception if the login screen isn't displayed. And in this case, we're checking for the lock logo. So raise unless lock logo exists. Quite a simple syntax, and we can give it a message. So let's say raise login screen was not displayed unless the lock logo exists. Okay, so the next step in the process that we just walked through is to enter the credentials. So simple syntax, type 100, press key, enter. We'll then type 1 as the password and press key, enter again. Okay, So that will get us through to the next screen, which has the OK button. So we just want to click on that OK button. OK button, click. The next screen is the associates screen, I believe. So we'll just be skipping that. Skip button, click. Actually, sorry, that's the screen where you enter customer details. So we just want to skip past that. And then we need to verify that we are successfully logged in. So I'm going to do raise unless the barcode logo exists. So we can give this a nice error message as well. The cashier was not successfully logged in. Okay, so I talked a bit earlier about building in robustness to your tests. So this is a good example. It will probably work just fine, but I noticed that when I clicked on the skip button earlier, it took a second or so to load the transaction component. So we need to put something in here so that it doesn't immediately fail. This will execute sequentially and incredibly quickly, unless we put in kind of gates along the way. So skip button click, and then we're looking for the barcode logo, but we don't want to check that the barcode logo exists immediately. We want to check that it exists within a certain amount of time. So this could be a duration in seconds, let's say 5 seconds. So then if after 5 seconds the barcode logo does not exist on the page, we'll get an error, and that will prove that this login function will fail because they haven't successfully logged in. Okay, so that's effectively everything we need for that. We've got our BDD layer at the top here. So the first one we're doing is I'm logged into the POS as a cashier. So I'll create that step definition here. I'm just going to create a new steps file through the IDE, xstore steps. And then we need to implement this. So we're calling basically the login function on the login screen. So login screen .login. And in the future, we could, add further details. We could pass through who we want to be logged in as, and then different credentials could be passed to it, depending on, maybe it's a back office manager who wants to log into the till, that kind of thing. But for now, this is more than enough. Login screen .login. So we've defined the first step. We might as well execute it. So I'll just press play in the IDE. The POS is back to the register login screen, so I'll switch to it. And as we run the test, I'll talk through it. Okay, it takes a few seconds to get started. And there we go. So it entered the login details incredibly quickly. You can see the test pass there. So it entered the login details incredibly quickly, so too quick to see. But then it pressed the buttons in the correct order, and then it's verified that the barcode image is present. So great, that's the first step in our scenario, and it's passing successfully. So let's look at the rest of the test. The remaining steps are when I add an item to the transaction and complete the transaction with exact cash, then the transaction is processed successfully. So let's step through that process on the till to see exactly what elements we need to collect. So first off, we'll just be typing in a product ID, 1004 should do it, pressing enter. That'll add the item to the transaction. In order to do exact cash, which is the next step, then we would need to click on the add tenders button. And then we'll either need to press enter or press the OK button. So the OK button probably click there. And then again, we could either press enter because it pre-fills the exact amount that's due. So when we're doing exact cash, we could just press the enter key on this screen, or we could hit the big enter button here. So if we hit that, then okay, so we're presented with the select a receipt method screen. We'll need to select print only for the purposes of this test. And then interesting, so we're returned to the commissioned associate screen. So in order to verify that the transaction's complete, we could check that one of these buttons is displayed, but these could be in more than one place based on what we've seen so far. So probably the commissioned associate text up here, that's what we'll search for to prove that the transaction is actually completed successfully. All right, so if we skip back to here and then go back to the IDE. So let's start recording these in Flare. Obviously, we're not going to record them on the login screen. The login screen is a separate screen. So let's create a transaction screen. There we go. So on the transaction screen, we're going to capture all those elements that we've just talked about. So on the till, I'll add the item to the transaction and then refresh the screen here. Now the add tenders button is here, so let's collect that. Great, and we'll call it the add tenders button. Next up, we click on the add tenders button and then we're presented with the sale tender options screen. So we're going to select the OK button next. OK button. And then the next step is the tender screen. So let's collect this big enter button and we'll call it enter button. All right, so when the enter button is pressed, exact cash is processed and we get the select receipt method screen. So we'll do print only for the receipt. Print only button. Okay, so those are the elements we need. And then there's a verification step at the end where we want to check that all of that's gone fine and we are on the commissioned associate screen. So let's use that commissioned associate label. Great. All right, so let's step back to the IDE. We can see we've got the new transaction screen screen object here. We've got our 5 elements created already. So thinking ahead, we've got basically 2 stages to this. We've got adding an item, which is one of the steps in our feature file. And then we've got completing the transaction with exact cash. So they're the next 2 things we need to do. Both of those take place on the transaction screen. So let's do add item as a function. And this time let's pass through or read in the product that they want to add. So let's call it product ID. And then basically all we're doing in order to enter an item is typing the product ID. And then we're pressing enter. So really simple. We can call this method. It will put whatever product ID we pass in, and then it will press the enter key, which will add it to the transaction. So let's do that as a step in our Xstore steps file. And this time it's going to be transaction screen. I can't remember what I called it. Add item, and then we'll pass through a product ID here. Let's call it 1004. All right, so the next step we'd need to do is to complete with the exact cash. So let's plan ahead and we'll do complete with exact cash on the transaction screen. All right, let's create that function. So the process is we first click on the add tender button, add tender buttons, add tenders button, and then we will click on the OK button, and then the enter button, And then lastly, the print only button. Right, and then the last thing we're going to do is verify that the commissioned associate label is present on the screen. Normally we would split some of these things out so they're on separate screens, or if you've got helper functions that span multiple screens, you'd set them up in a different file. But for the purposes of this demo, we'll just raise an error unless this is displayed. So raise unless the commissioned associate label exists within, let's say, 5 seconds again. And let's give it a nice message. The transaction was not successful. All right, so we've got our complete with exact cache method. We actually need to put that into this step. So let's create a new step. Great, so this needs to come down there. And we're not doing the last step at the moment because we need a separate verification step for that. So, but we've got enough. We can run this, and this will do the complete transaction. So switching over to the till, I need to get it back to that default state, which is, signed out, logged out, so that the test can start. All right, so I will press play on the IDE, and then we'll watch the test. Okay, so it's logged in, clicking OK, and then skip. And now it should enter an item. Yeah, add tenders. Clicked on the enter button, and there we go. And now it's just verifying that the commissioned associate is displayed. There we go, test passed. So it's executed all of the steps apart from the last step. And it's completed a transaction with exact cache. So that is fundamentally a good regression test. Obviously, there are a magnitude of different variations we could do on that. You'd want to choose your scenarios on a risk-based basis. But that's a good start. So we've completed an exact cache, a simple cache transaction on the till. A new software update comes down to the till, and you're happy that you can take exact cache. In terms of making our tests more robust, there's a couple of things we can look at here. So if we look at the login screen object and our login method that we built, we've got, the first thing we do is check that the lock logo exists before we enter our credentials. And that's a pretty good rule of thumb for how we want to do it. Anytime there's a screen transition, we want to check that the screen has fully transitioned before we start typing in the next field. So for example, here we typed 100, pressed enter, typed 1, pressed enter. All of this happened in a fraction of a second. It worked perfectly fine on this version of Xstore, on this particular till. But if it's an older version of the software or a slower till, it might not have actually displayed the password field here before we pressed 1. And then you'd likely not log in successfully. So if we switch to the POS, we can see here that the first message is scan or key your employee ID to sign on. As soon as we do that, we enter 100, press enter, then the message becomes key your password to complete sign on. So that's useful. If we switch back to the code, we could put a check here that basically does the same as this. We can check that that message is displayed before we type 1 and enter. And that's just one of the ways you can build robustness into your test from the start. Obviously using exists within a certain time frame rather than exists, which will be immediate. Exists will be more performant because it's going to make that decision immediately. So if you're looking to fail a test based on some criteria, then this will be very, very quick. But you need to give some tolerance for slow running machines or software that's older that doesn't process as quickly. So yeah, just a couple of things to keep in mind there. If I switch over to another project then, we can see the kind of flows that are possible. So we've done a very basic exact cash transaction, but we can do complex flows. So here's an example here: process a return. Given there's a completed sale, which is basically what we've just done, when I initiate return for that sale, then it can be completed successfully. So that's a simple return flow. A more complex one would be entering a barcode from a receipt. So obviously, we don't have the barcode from the receipt printer. So in order to automate this, what we did was when it gets to the end of the transaction, you can choose to print the receipt, or you can choose to email the receipt. So we emailed the receipt to an inbox that we had access to via API. We found the email based on the customer email address. We then scraped that email for the barcode, and then we just entered the barcode in the same way as we entered the product ID in the example earlier. So that's a way of kind of automating something that doesn't initially seem like it should be possible. But yeah, receipt barcode can be key for return. And then we just verified that the original transaction items that we ourselves put through were displayed when the barcode was used. So something to mention here as well, we've got tags for each of these scenarios. These are really useful to include or exclude certain tests depending on whether they're relevant for a particular test run. So say you've got a UK-based till and a US-based till. You might have different requirements for those tills, but the interface is exactly the same. So what you want to do is, let's say, for example, this barcode test isn't possible in the UK. It's only possible in the US. So we would tag this test with something particular, and then when we create our test runs, we wouldn't include it in the UK test. In fact, we'd specifically exclude it, function 68. And that's a way of working around regional variances. We can also tag entire features. So if, for example, returns are completely impossible in the UK for some reason, then we just tag this as not UK or something like that, something very readable. These tags also help us clean up. So we've talked about a flow through the system, but we also need to, at the end of a test, recover back to the login screen. So if, for example, a test was tagged with front office, we could do particular behavior based on knowing that we're in the front office that will exit the test and get back to the login screen. These are called hooks. So here's an example of one for an exit store test, or it could be any close open test that's tagged with store close. So it involves a store close procedure. And then, so in the hooks file, we're just calling after, and it just means after every scenario then that includes the store close tag. Then we call this function exit store close test. So let's click through to there. And all this is doing is checking that unless the store is open, then open it. Unless the register is open, then open it. And this can be called after a scenario. It could be called before a scenario under specific circumstances. But we find that the best way to do it is to always return after the scenario, return the till to the register login screen. So no matter where you are, back office, training mode, some depths of the system, a complex return flow, it needs to be able to exit back to the register login screen so the next test can start. And similarly with test runs, we always want the register to be open, we want the store to be open, we want transactions to be able to be taken. So these hooks can work before all, after all, or after, before and after a particular scenario. So that's just something to bear in mind. These are really useful for basically just restoring the state of your tests. Right, we've talked about creating a basic test. We've talked about using Flare to accelerate the process. We talked about recovery flows and robustness of the tests. But something that's very important to us at Test Evolve is transparency and reporting. So this is our cloud reporting platform called Halo. And I want to show you just how transparent it is. So we can see our latest runs here for a particular project for this customer. We click through, we've got all the details. This is just some test data, but 50% passing, 100% of the tests are finished, the time it's taken, the average scenario time. We've got the trend history of this particular test run. And then we can click through on the features tab to this customer's feature. And this provides the lowest level of reporting. So we've got the traceability to the original requirement. This scenario, home phone and last name fields are the only mandatory fields. And it's failed. It's got these tags here. We can see that the given step and the when step passed, but the then step failed. And we have a stack trace here. So we can see that the error message is customer was not added to the transaction. We can see the desktop app screenshot. So we can see the user was actually logged out, and that's why it was not on the transaction screen. So that's really useful information for a tester investigating, after a regression run overnight, perhaps against multiple tills. They can come in, they can see all their information in one place. They've got the evidence here that they need. So if, for example, they have Jira, they could raise the bug in Jira. You can select a particular project in Jira, you can give it a summary, but the screenshot and the details, the traceability to particular requirements and the stack trace is all in the ticket as by default. So we just will be able to raise the ticket there, get that information to the developers as quickly as possible. I'd also like to mention our partner OLR. So they've been an Oracle partner for over 20 years. They offer system implementation and retail consulting services. And more recently, they're offering testing services. So using the TestEvolve tool, they can provide automated regression testing services. They have built several quick start regression test packs for several Oracle products, including Xstore. And most recently, we've worked with them to build an integration to a robot that will allow you to test your payment solutions. So it's a robot that can have up to 4 card readers, different card readers, if you like, at the same time. It will allow you to insert card, put in a PIN, contactless payments, swiping the card, even putting an email address into the touchscreen, things like that. The robot's incredibly capable. So we built an integration, and obviously in the quick start regression test packs that OLR provide, this will be included. So the robot has a multiplexer, so you can test several different card types. So just one test flow, but different card types as a scenario under each test. So if you're interested in that, olrretail.com. Okay, so that's all the time I have this evening for the webinar. It's a big subject. There's a lot of stuff I wasn't able to show you. If you would like to see more, or you are interested in seeing how we can help you further, then please get in contact. You can visit us at testevolve.com, or if you want to send us an email, info@testevolve.com, or if you want to reach out to me personally, mark.sweetlove@testevolve.com. All our documentation is at testevolve.github.io. And thanks for joining, and see you next time. Thanks.